And the first thing I'm going to do is I'm going to label all my resistors, and let's make sure we label them the same. Here's R1, 2, 3, 4, 5, 6, 7, 8.
I'm sure this doesn't get edited.
See how much time I have.
Oh, we got.
Okay, so I'm going to do the old-fashioned way here. All right. So there's our charts. So now I'm going to fill in the resistors. 10 ohms, 10 ohms, 20 ohms. Okay, and we're going to call this 120 volts. Okay, so, do you have a question? Oh, it does? I guess we'll do it at that. Okay, so what I'm going to do is I want you to imagine what would happen if I could unplug at these two terminals and straighten out the circuit. Let's see if we can figure out what that would look like. We have R1 here, and we have this complex combination. And we have one more complex combination. So again, I'm taking it from the top, so I take it from the top and straighten out these lines. I have 10 ohms here. I have 10, 20, 5, 10. 5, 10. Okay, now I'm going to go down and step by step, I'm going to simplify the circuit. So my first step is to actually combine these series that are part of a parallel circuit. And in series, you can add the resistors. So when I add 10 and 20 together, I get 30, and I still have 5 and 10. When I add 5 and 10 here, I get 15. Okay, so questions so far? Okay, so next, I'm going to have to combine the resistors in parallel. So here I'm going to say 1 over the effective resistance equals 1 over 30 plus 1 over 5 plus 1 over 10. Again, you can change to fractions. This would be 10 over 30, and then you would flip it to get 3. Or you can use a calculator. You can do a similar process here. 1 over 15, 1 over 10, 1 over 3 over 30 plus 2 over 30 plus 3 over 30. 5 over 30, and then you flip it, 30 over 5, 6. All right. So now I have 3 resistors in a row. Housekeeping. Okay, so this is 10 ohms. This is 3 ohms. And finally, our last step is to add these 3 together. 10 plus 3 plus 6 is 19 ohms. Okay? Okay, so now what next? Find the current, find the total current. Good. So we're going to find the total current from the total voltage. So the total voltage was 9 volts. So if you have 9 volts and 19 ohms, you can divide and you would get that the current is 9/19. That's what it is. I could have. But it is. Now this current carries back. Current here is 9/19 amps. And it goes to each one of these resistors. So to get each voltage, I would take 10 ohms. For the first one, I would take 10 ohms, 9/19 amps, and I would get 90/19 volts. So this would be 90/19 volts. If I took 9/19 times 3, I would get 27/19 volts. And if I took 9/19 times 6, I would get 54/19 volts. Now, as far as our chart goes, is there anything we can fill in? Yeah. Up here on the 10 ohm resistor, our very first resistor, we have that one figured out. We know that the current is 9/19, and we know that the voltage is 90/19. Additionally, going back, for the next resistor combination, we've got 27/19 volts. That will work for the 5 ohm and the 10 ohm. It won't work for these two, but it'll work for the 5 ohm and the 10 ohm. Did I say that was 27/19?
Oh, well, that just makes it easier then.
Yes, it does. So 27/19 works for the 5 and the 10, which I have labeled as R4 and R5. So for R4 and R5, I'm going to put 27/19. And then, what other resistor can I fill in? I guess I can fill in these currents, huh? Oh, no, I will be able to fill in these currents in a minute. How about R6? Can I do R6? 10 ohm? How many volts are across this? 54/19. Okay, cool. So, once I have, so let's just pause for a minute because I have some things filled in so I can find these currents. I can find these currents by dividing, by using Ohm's law, so E equals IR. So if I take 27/19 and I divide by 5, I would get 27 times 5.
It's like a million.
95. Okay, and then 27/19 divided by 10 is 27 over 190. I know they are. And this is 54 over 190. We could change all of that. Okay. So what next? How can I find the current in this branch right here? Good. So these two resistors together have a resistance of 30, and the voltage across here was 27/19. So if I use 27/19 as my voltage, and I use 30 ohms, if I divide, I'll get the current in that branch. So I'm going to have to take 27/19 divided by 30. Pardon? Is it 9 over 190? Okay. Now that's going to be the current in these two resistors. Because the current is the same in this graph. So that's resistor 2 and resistor 3. Got those filled in, so now I can figure out the voltage by multiplying. 90 over 190. 80 over 190. And then I just got one more left. I'm going to figure out the current in resistor 7. I'll take a minute and see if we can figure it out. 18 over 95. Put both currents here. And then we multiply to get the voltages, so you get 180 over 95. I didn't even use these. And then 90. 90. So this one is really kind of a beast.
Wait, for the
Yes.
date, for the current, it should be 1895.
Oh, the second one?
Yeah.
Yeah, thank you.
And the same with the should be 1895.
It's inventive.
Okay, so your next set of homework questions asks you to analyze more complex circuits. Most of them are not this bad, they're more like the earlier examples, but the problem set questions are 23 through 32.